Welcome back to the Exchange Server 2016 course on Mailbox Databases. In this module, we're going to talk about how do we plan and implement high availability. High availability has become a really important concept in Exchange. And nowadays, you actually don't have an excuse to implement a highly available Exchange server because it's so easy to do with database availability groups. So let's get started. In this module, we're going to talk about high availability in general, and then we're going to talk about how do we configure the concept that creates high availability in Exchange called database availability groups, and how do we maintain database availability groups in Exchange. High availability is one of those things that over time has become really easy in Exchange to do. I don't know if you've been involved with deployments of 15 years ago before, Joe, but I remember a time where it was extremely hard to create a highly available Exchange server.
There's a lot of things to consider, so let's just go down the list. Data center infrastructure.
Yep. Yeah, there's things like electricity. Do you have highly available electricity in your environment?
Network. Do you have a redundant ISP
Yes.
set up?
Do you have redundant servers to set up?
Yep.
Do you have redundant storage?
The appropriate amount of bandwidth, internet connectivity.
Yep. So there's so many things that builds up high availability, and you don't just think about the Exchange server itself. You have to think about all the components around it.
Absolutely.
As well that causes you to have high availability.
Yes.
So with high availability in Exchange, we do that with database availability groups, but once a database availability group or DAG is there, there's still things around it, like for example your data center, which we mentioned. If your data center goes down, then it doesn't matter if you have a DAG. If all the servers is part of that same DAG in the same data center, then Exchange is down. So
ideally, you want to have another data center
yes,
for site resilience.
and that's why we have site resilience.
Yes.
Yeah. So when we look at high availability for database availability groups, we have to think about how do we deploy this. So the components of high availability is really important, like we mentioned, that supports the high availability in your environment. Database availability group introduces those components and helps you to get rid of any of the what we call failure domains that can happen. A server is a typical failure domain with its storage associated with that. If that breaks, then you can fail to another server and carry on working without the users noticing. Database copies is another component of high availability. If a database copy exists on another server and that exists inside of the database availability group, then it can fail over to other servers. If you have a DAG, a database availability group, and there's only 2 databases, then it can only fail over to another server. If something happens again, then your service is going to be down. So you have to think about how many copies do you need to sustain a bunch of failures if there is a possibility. Another thing that you need to consider is the concept of quorums. And this is something that database availability groups use under the covers because it uses failover clustering. Failover clustering is a technology inside of Windows Server that allows you to run multiple servers and resources on servers and fail that resource from one server to another server. And for that concept to work, multiple servers working together to give a service to users, it needs to have a mechanism to decide which servers are going to be currently serving users, which servers is going to currently receive replication traffic, and so on. So that arbitration that needs to happens through a concept of failover clustering and quorums. So quorum is a method the failover clustering uses to decide which servers is currently active, which servers is passive, which servers should actually not do anything because they are isolated. And so quorums is a very important concept in Exchange and needs to be planned correctly so that you don't have the wrong effects when you have an outage. The active manager is another component that runs on this failover cluster that in exchange that decides which databases is going to be mounted and active, which databases is going to be passive and receive replication traffic. And it also provides the client access services layer the knowledge to know which database it needs to connect to. The client access services layer talks to the active manager to say, I need to connect to the database of Joe, and that the active manager will say, oh, this database is currently running on this server. So, and then the client access services will be able to know which database to connect to. And then continuous replication is another concept that's important in Exchange, where this is the mechanism where the log files are replicated to other servers and applied on those other servers so that you have redundant copies of your databases. So we spoke about some of the components of this high availability. We talked about the data center infrastructure. We talked about the server hardware. The storage is another component. Storage is a mechanical component. Anything that's mechanical, that spins all the time or goes up and down all the time, those things are prone to wear and tear and they can break. Network infrastructure is another component. Internet could be another issue. If you don't have redundant connections, internet connections, then if your ISP connection fails, then people are not going to be able to access their mailboxes from the internet. And then network services, so things like switches and so on, or network cables and so on, those have to be redundant as well, because if they go down, if somebody trips over a wire, then mail could be down and people could be crying. So consider all of those. So let's talk about the database availability group. The database availability group is this collection of servers that forms the high availability unit. When we create a database availability group, we can then add servers to that database availability group. And once we have servers in that tag, then we can add databases to those servers and make them replicate between those servers. So the big container is called a tag. In there, you add your servers, and then you add your databases to the servers that needs to, or on the servers that they need to be, and then they replicate between each other. You cannot replicate a database outside of that DAG. It can only replicate to a server in the DAG. A DAG can only have 16 members, so you can only have 16 databases, servers, mailbox servers in that DAG, which means you can have 16 copies of any database. So if you need a SLA or something like that, then you can replicate a database to any of the 16 servers on that, in that database availability group. One server can have up to 100 database copies on that server. So this means you can have 1,600 databases in a DAG in total. Now in Exchange 2016, failovers are 33% faster, so we are a lot more efficient in terms of how the replication happens, so that if there's a failure, that failover happens a lot quicker than it used to happen in previous versions of Exchange. So you know, this is something that users never really notice, but sometimes there was a bit of a, maybe you have Outlook and it showed you a pop-up, it couldn't connect to the Exchange server, and then users would notice that, and then a few seconds later it will connect again and carry on, but now they wouldn't even see that pop-up anymore. So let's look at a few examples of database availability groups. So here we have 5 servers, 5 Exchange servers that's part of a database availability group. And then we have a bunch of databases mounted on that servers. And the databases in green are currently active databases. And the databases in blue are currently passive databases. So they receive the replication traffic. You see here that if you look at database 1, for example, database 1 is not on all servers. So you don't have to put a database on every server. So database 1 is on this server. Database 1 is obviously passive on another server, and it's also on this server. It's not on every server. It can only be active on one server. Other databases like this database 4, it's the same story. It's active on server 2, EX2, and it's passive on the other server. So there's database 4 on that server as well, and over there.
Would it be more accurate to say, Martin, that these are actually database copies as opposed to databases?
So think about the database as almost like a logical concept that lives in memory of those servers, but the actual copies is the physical copy of those databases. So those are instances of that database that runs across those servers. Okay, so when you have a database availability group like this example, you can do nice things. For example, here's a server in maintenance mode. So we need to do some Windows updates, or we need to do some firmware updates on the physical hardware or something like that. So we took that server out of commission, and the database 4 that was currently active on that server is now failed over to this server EX5, and it's now running on there, and nobody knows. It just carries on working. This server is now serving connections for users on that server, and this server is out of commission. We are doing updates to that server, so life carries on, no problem. We can go further and say, what if now we're in maintenance mode? What if we have a failure? Something happened to that server. There was a fire, or there was maybe not something that bad. Maybe it's just a hardware component that failed, like a fan or something, like in a power supply that failed. Now this server is out of commission. It's no longer up and running. Because we have 5 servers, and now 2 is out of commission, 3 is still a quorum, 3 out of the 5. That DB2 that was running on that server is still is failed over to this EX1 server, and so it's now up and running there. Nobody notices. You carry on working. You basically have 2 servers out of commission, and you carry on working. We carry on with this example. Now EX2 is out of commission, and we finished our updates. It's now out of maintenance. We bring it back online. What immediately happens is it catches up with the replication. So DB4 replicates all the missing log files that it needed, DB1 as well, and it gets up to date in terms of the infrastructure and the data and so on, so that we don't have any log files missing. Then once we fix our Exchange server as well, that went out of commission by accident, that will replicate as well and gets up to date, so that all the databases are current. And then finally, we can then fail the databases back to that server to make sure that those servers are serving users again. So very simple concept to make sure that the servers are up to date all the time. So database copies, we talked about this. This is the scope of replication. So a database copy can either be a source or a target at any given time. A source is an active database, and a passive is a database that's actually receiving the replication. There can only be one copy in a database active at a time. You can't have the same database active on 2 different servers, because then this server is going to serve some users and another server is going to serve other users, and then those 2 copies are going to get divergent, and they're going to become 2 different copies. So you can't have that. Only one copy can be active at a time. And the server cannot host more than one copy of a database. It cannot replicate to itself. It needs to replicate to another server. So those are the rules about mailbox database copies. We talked about quorums a little bit, but let's go into a little bit more detail. A quorum is that mechanism that Exchange uses to get consensus across all the members of the servers to say who is currently serving users, who's not serving users, and so on. And this is to prevent a split blame scenario. So say you have 4 servers or you have 6 servers, and 3 of those servers is in one data center and another 3 is in another data center, and there's a network problem between the 2. Now, the 3 servers on the one side and the 3 servers on the other side doesn't know about the other servers, and so they're going to say, I'm going to mount database and serve users. But this causes a problem because now the same database is active in 2 different servers. So you need to prevent that scenario, and that's called a split brain. You don't want that. And so Exchange uses a quorum, and it gives every server a vote. And so you need to have a majority of votes to be able to mount the databases. And if you don't have a majority, then you're going to just stay offline. That is the way quorums work. Now, when in a scenario like that, where you have 3 servers on the one side and 3 servers on the other side, you don't have a majority on either side. So you need a tiebreaker. You need another vote. And that is where Exchange uses a concept called a file share witness. And this is another server that you place a file share on, and the Exchange servers will both on each side try and make a connection to that file share witness and place a lock on that file share witness. And the side that is able to do that successfully gets an extra vote. So in the scenario where we have 3 servers on the one side and 3 servers on the other side, the one side that wins will basically get 4 votes and thereby achieve majority and will be able to mount databases and serve users. A concept that we also have is we have the ability to designate some servers as non-voting nodes. This is a feature that was introduced in Windows Server 2012. And this also allows you to say this one side that's got 3 votes has, this is votes that is important, but the other side that I don't want to ever fail over to, I'm going to remove their votes. So the majority will always be on the other side because that will be 3 votes, and the other side have no votes, so they wouldn't even get to 3. So they would be non-votes. So that's helps you to sort of contain where the failover will happen to. The Active Manager is the brain inside of Exchange that allows you to decide which databases are currently mounted, which ones are active. So this is the resource manager of high availability. It runs on every server inside the DAG, and one of them is called the primary active manager, and this is the one that is actually running the cluster resource, and the others are the SAM, the secondary active manager. And so they decide which servers will be active, which databases will be active, which servers will be passive. And the client access services will then use the active manager to decide or to know where to connect to. It's in-memory information. The configuration of Active Manager is not stored in Active Directory. It's just there. It's live information for client access services to interact with. It's once you've rebooted servers and so on, it will rebuild that information again in memory. Continuous replication is the other component of Exchange that allows you to replicate these databases. So that is the mechanism that we use to replicate databases. And there's 2 ways that we do replication in Exchange. There's file mode and block mode. File mode is where the databases generates a 1 megabyte transaction log file on each mailbox server, and then it copies that log file to the other servers so that those servers are up to date, and it can apply those transaction logs to databases and make sure that those databases are up to date and have the current information. Block mode works with memory. So the memory on those servers also contains a copy of the databases, and those transaction logs are then copied to those servers on the other side and kept up to date on those servers on the other side. So it's sort of more up to date when it uses block mode, because it's copying the lock transactions from memory in the ESC lock buffer on those servers to the other servers, and then it applies it to those servers, and it keeps the databases up to date. Each server then generates a log file on its storage and then applies it to the database on that server specifically. So it's a nice way of keeping those databases up to date. So that is the theory around DAGs. Let's talk about database availability groups in general. So when you physically create them, you can manage them, and you can create new databases, seed mailbox databases, create lag copies. This is a database that is behind the other databases. In some cases, for recovery reasons, you may want to keep one database behind so that you can fail to a previous point in time. If I have a database and I say this database is lagged, then I lag it maybe for a week, then it would keep all the transaction logs up to a week and then start applying the oldest transaction log to that database. Once that database is, I have a failure scenario, I can say, well, maybe I need to recover to the point before the failure, and I have all the transaction logs up to that point, and I can just remove the transaction logs that I don't need and recover to a point before the failure. So it
protects you against logical corruption and things like that happen.
Sometimes it's a very rare thing, logical corruption. But if you want to be protected against logical corruption, then you can do that. Or maybe a malicious administrator did something, and you want to have. It's actually like time travel. You know, you have
a snapshot back in time.
Yes, you can go to any point in time for the last week or up to 2 weeks. So if that sounds appealing to you, that you have this ability, say, there was a moment in this last week that was a good time to be in, then you can go back to that moment and recover to that moment. So let's just quickly, I want to show you a couple of things in Exchange to show the database availability group. So I'll just log in quickly into my demo machine. So to manage database availability groups, you can go into your Exchange Admin Center, which is amazing. Previous versions of Exchange, all of this was PowerShell, so you had to do this in PowerShell. But you can now create database availability groups and manage database availability groups in Exchange. You go to servers, and then you go to, there's a few tabs here, servers, databases, and here's one for database availability group. And it lists all the DAGs in your organization. And you can create a new DAG by clicking on the plus sign. And first thing that you have to do is you have to specify a database availability group. You specify a witness server. So this is that file share witness that it uses to have a mechanism to get quorum. You specify the directory it needs to create a share on, and then you can specify an IP address of that database availability group. You don't have to specify one, because now we have the ability to have IP-less database availability groups. Once you've created all of this, it actually just created a container in configuration. This doesn't exist on any physical server at that point. What you need to do at that point is you need to add a server to a database availability group. And if you add a server to a database availability group, I'm just going to edit my current database availability group. I add new members to my database availability group, and then I will be able to configure that database availability group, and it will actually go and install failover clustering on that server and set that server up. There's certain things that we can do as well. In here, this is where I add my database availability groups, is add members. The moment I click on the plus sign, I can add more servers to this DAG, or I can remove servers from this DAG. Also, in terms of the properties of the server, I can set up, change the IP address and so on of this database availability group in here as well. Here I can also add new database availability networks. This is if you want to have dedicated networks for replication or for client traffic. We really recommend that you don't have dedicated networks anymore unless you have some sort of special requirement. Maybe you can have a dedicated network, but it's just unnecessary complexity.
Wasn't it recommended in 2013, and then that recommendation was minimized just to use a single network?
Yeah.
Plus, speaking of networks and TCP/IP, I think now the recommendation is to use IP-less DAGs.
Yes. Yeah. So and so you can configure everything inside of your database availability groups in the Exchange Admin Center. So that is a really nice way, because it's a one-stop shop for database availability groups. Once you have your database availability groups created with the servers added to them, then you can manage your databases and your copies of your databases. So you can say, this database here, I want to add a copy of this database to another server. So I can modify the copies of the server. You see the properties of this copy, what's the activation preference of this copy as well. So you manage all the databases of your that's in your DAGs inside of the Exchange Admin Center as well. If I click here and I say I want to add a database copy, then the first thing that I have to specify is I have to specify the server that I want to replicate this database to. Click on OK. I can set a preference, servers that's currently hosting this database, so that I can say where to reseed this database from. Click on Save, then it will go and create another database. Currently, this database has circular logging enabled. I need to remove that to be able to create another copy. But this is where you need to, this is where you're going to create new databases. So that concludes our demo for database availability groups. So in DAGS, we also have this ability to have maintenance mode. And this is a way that you can tell Exchange to actually move all active databases, move all queues and so on to other servers, so that this server is not actively serving users. Like the example that we use where we took a server out of commission to do Windows updates. So maintenance mode allows you to do that. So when you introduce maintenance mode, you can
it takes servers in or out of the service without actually failing them over.
Yeah.
In a nutshell.
Well, if there's databases running on them, it fails over those databases, but it's not a brute force failover. It's a graceful switch.
That's a good way to look at it.
I think the word they use is switch over. You switch that over to another side, and it's not a failure. So it doesn't rely on the automatic database failover process, because it moves the data, it moves all the log files and all of that stuff to the other server, so you don't lose any information. If you don't do this, then it's going to see, oh, the server is down, and it's going to just do automatic failover. So it just does a smooth switch over. You would do this when you want to do updates to Exchange servers or updates to the Windows operating system, or if you want to do hardware upgrades and so on. So that is what maintenance mode is for.
I assume there's differences between doing this procedure on a standalone server versus a member of a DAG?
Yeah. So when you do it on a standalone server, when you do maintenance, you have to enable maintenance mode. When you enable maintenance mode, it will drain all the transport queues. It will then restart the transport services and deliver all the messages. It will pause the cluster node. It will move all the cluster databases to other servers, so that's running on other servers. It will wait for the transport queues to clear completely, and then it will be in maintenance mode. And then you can patch that server. And once that is completed, you have to disable maintenance mode again, and then you tell the Exchange server that you want to be out of maintenance mode. You resume the cluster mode. That will then allow you to fail back all the databases. It will start receiving mail on queues as well, and it restarts all the transport services and rebalance the database copy so that your database availability group is balanced and all servers are currently working in the environment. Another feature is AutoReseed. AutoReseed is a feature that was introduced in Exchange 2013 that allows you to auto-reseed a failed database if a database is down because the storage, the disk that hosted that database broke or something like that, and it's no longer available. So when you have AutoReseed configured, then you configure these extra spare disks on the Exchange servers, and you designate them through mount points to the Exchange server, and you tell Exchange that here's volumes available for you to reseed databases. And this helps you to avoid outages, so that if a disk fails and there's a spare disk around, Exchange will just automatically use that spare and replicate the database from another server and make it part of the high availability system, so that you don't have to immediately go and replace that disk. You can then wait for a next maintenance cycle to go and replace that disk, but you don't lose any redundancy, because every time you lose some redundancy, then you're one closer step to ultimate failure. But because you've built in this extra spare disk, it's available for the Exchange system to mount and to replicate the databases to, and survive another failure and live another day. So it's a great technique that they built into the system, and it's some of the learnings they got from Office 365 that I applied to the Exchange Server 2016. So if one disk fails, it can automatically replicate that.
I think you've got a graphic that kind of illustrates that, no?
Yeah. So in this graphic, you see that, for example, if that disk fails, Exchange will then automatically use one of the spares, mount that in the spare, and replicate the database from another server to that spare, and life is good, and you carry on using your Exchange system. So seamless, but this is something that you need to configure beforehand. You need to make Exchange aware of those spare volumes that you have in Exchange, so that if Exchange goes down, that it knows that those disks are there and it can reuse them for AutoReseed.
Wow, again, a lot of important stuff, a lot going on, a lot of moving parts with DAGS and AutoReseed. If you want to learn more, check out the Mailbox course on EDX.
Yes, very important. So how do you configure this and make sure that it works? Obviously, you have to test this to make sure, you know, maybe you have some sort of procedure where you dismount a disk in the volume manager of the disk manager of that server. That's good tips. And look at the edX course. We cover all of those, the configuration items around AutoReseed and a lot of the detail of how it works. And that concludes our module on high availability. Stay tuned for site resilience.